All right, let's dive into this explainer and take you on a journey from absolute electronics beginner to a wireless hardware master. If you've ever looked at a crazy jumble of wires, blinking lights, and circuit boards and thought it looked like pure magic, well, you are absolutely in the right place. Today, we're going to demystify that magic. We'll start with the simplest possible circuit, and by the end of this explainer, you're going to understand exactly how to wirelessly control a complex 64 LED display right from a custom app on your phone. So here's our roadmap for today. First up, the Arduino hardware basics. Then, blinking your first LED. After that, adding wireless Bluetooth control, building a mobile app, and finally, mastering the LED matrix.
Okay, section 1. The Arduino hardware basics. Understanding the brain of your project.
The absolute most crucial point here is that the Arduino Uno acts as the brain of your circuit. It's a microcontroller, which means you can really just think of it as a tiny, self-contained computer. You write your thoughts out in the form of code on your laptop, and then you upload those thoughts directly to this brain. The brain then reads those instructions and sends electrical signals out to the muscles and senses of your project, which are just your components, things like lights, motors, and sensors. Moving right along to section 2, blinking your first LED, the classic hello world of electronics. To actually build this, you only need 4 really basic components to get started. You'll need your Arduino Uno, a breadboard with some jumper wires so you can make connections without soldering, a standard light-emitting diode or LED, and a resistor somewhere in the ballpark of 220 to 1,000 ohms. Wiring this whole thing up is incredibly straightforward. First, you just connect your resistor to digital pin 13 on the Arduino. Then, connect the LED's long leg, which is the positive anode, to the other end of that resistor. Finally, take the short leg, the negative cathode, and connect it back to the ground pin on the Arduino. Now that resistor, it is absolutely essential here. Thanks to Ohm's law, it limits the current flowing through your circuit. If you decide to skip the resistor, your LED is going to pull way too much current, and you could potentially burn out both the LED and your Arduino's output pin. Seriously, always protect your hardware. Now, when we translate that physical wiring into code, every single Arduino program relies on 2 main blocks. The setup function is kind of like waking up in the morning. It runs exactly 1 time just to get everything ready. In our case, it's telling the Arduino that pin 13 is going to be used as an output. The loop function, on the other hand, is your daily routine. It executes its contents repeatedly, over and over, in an endless loop until you literally pull the plug. Inside that loop, that's where we control the light. By using the digital write command in your code, we literally tell pin 13 to go high or low. High sends 5 volts to the pin, snapping the LED on. Low drops it right back to 0 volts, turning it off. We simply sandwich those 2 commands with a delay of 1,000, which tells the brain to pause for 1,000 milliseconds, so exactly 1 second, between flipping the switch. And just like that, boom, you have a blinking light. So a blinking LED is a fantastic start, right? You've proven you can write code to control the physical world. But it kind of begs the question of how we can interact with it remotely. What if we don't want to rely on pre-programmed delays? What if we want to turn it on and off from, say, entirely across the room? That brings us to section 3, adding wireless Bluetooth control. Cutting the cords with the HC05. We are definitely leveling up our component list here with the HC05 Bluetooth module. This clever little board enables serial communication between your Arduino and other Bluetooth devices, like your smartphone. We'll still need our basic LED setup, but we're also bringing in a few extra resistors to create something called a voltage divider. So a voltage divider is what safely connects your 5-volt Arduino to the HC05. You see, the HC05's receiving pin is pretty sensitive. It operates best at around 3.3 volts, not the full 5 volts the Arduino Uno pushes out. A voltage divider just uses 2 resistors to safely step down that voltage. It's a super vital technique to learn early on because it ensures we don't completely fry our brand new Bluetooth module with too much power. The wiring logic here is literally like a conversation. The Arduino's TX or transmit pin has to connect to the HC05's RX or receive pin running right through that voltage divider we just talked about. Then the HC05's TX connects back to the Arduino's RX. They're crossing over to talk to each other. Now here is a massively important insider tip. Remember, you absolutely must disconnect the RX and TX wires when uploading your new code from your computer to the Arduino. The Arduino uses those exact same pins to receive the code via USB. If the Bluetooth module is plugged in during an upload, the signals crash into each other and your upload is going to fail every single time.
Okay, Section 4, Building a Mobile App Using MIT App Inventor Basics. So MIT App Inventor lets you build this app using really simple visual blocks. Honestly, it requires almost zero prior programming knowledge. You literally just drag and drop. You're going to need a list picker, which lets your phone scan for nearby Bluetooth devices like your new HC05. Then you drop in a hidden Bluetooth client component that handles the actual wireless connection behind the scenes. Finally, you just design a quick interface with a couple of big, friendly on and off buttons.
The logic you set up in the App Inventor is just brilliantly simple. When you hit the On button in your custom app, it sends the text character 1 right over the Bluetooth waves. When you hit Off, it sends a 0. Back on the Arduino side of things, your code uses a command called serial.available to constantly listen for those incoming messages. When it finally hears a 1, it triggers the LED to go high. Now, the absolute crucial point in your Arduino code here is how you store that incoming message. As one of our sources perfectly points out, you just have to be careful to use char with text and not int while programming. Because your app is sending a text character, a literal 1 or 0, you must declare your reading variable as a char for character, not an int for integer. If you try to read it as an integer, the Arduino gets totally confused by the data type, and your light will stubbornly refuse to turn on. It is a super common trap, but hey, now you know how to avoid it. Finally, Section 5, Mastering the LED Matrix, Multiplying the Complexity. To build an 8x8 matrix, we are vastly increasing our component count. We've got the matrix itself, containing 64 individual LEDs, 8 1-kilo-ohm resistors to protect the rows, and 2 potentiometers. Those are basically just twistable knobs connected to your analog pins to help us manually control exactly which LED on the grid is lit up. Now you might be wondering, wait, an Arduino Uno doesn't even have 64 digital pins. How on earth do we control all these lights? Well, the answer is a brilliant technique called row column scanning. Instead of wiring up 64 individual pins, this technique cleverly groups the LEDs. It connects all the positive anodes in a horizontal line into a single row pin, and all the negative cathodes in a vertical line into a single column pin. This lets you control the entire 64 LED board using just 16 pins on your microcontroller. It's genius! But fair warning, the physical pin mapping on the back of an LED matrix is rarely in a logical order. As you map it out, matrix pin 9 controls row 1, but matrix pin 13 controls column 1. In your code, you're going to use arrays to organize this chaos, assigning these specific matrix pins to your Arduino's digital pins. That way, you can program everything logically, even if the physical wiring looks like a total bowl of spaghetti. The logic to actually light a specific dot on this grid all boils down to a difference in voltage potential. If a row is high at 5 volts and a column is also high at 5 volts, well, there's no difference in potential, so no current flows, and the LED stays off. And exactly the same thing happens if both are low. So to make an individual LED light up safely and predictably, you've got to follow these specific steps. First, set its specific row high. Then, make sure all the columns are set high so everything defaults to off. Finally, set only the specific targeted column to low. This creates a perfect path for the voltage to flow from the high row right through the LED and down into the low column. By doing this scanning process incredibly fast, literally turning rows and columns on and off way faster than the human eye can even perceive, your Arduino brain can draw complex shapes, animations, and even scrolling text on the matrix muscles. Just look at how far we've come. You've gone from a single blinking light to wiring a voltage divider for wireless Bluetooth control, all the way up to understanding the high-speed logic of row-column scanning for complex matrices. Whether it's one single light or 1,000, the fundamental rules of current, code, and control are exactly the same. You have the tools now, and you totally understand the logic. So, what amazing device are you going to dream up next?